Today I'll be showing you guys how to do this. You might be thinking, well, that's not very special. You just have a partitioned PCG system. But did you notice that I'm also partitioning the actual splines? That's right, spline mesh partitioning. And it's actually very simple to set up. So in this tutorial, I'll show you guys how to do this. Now, you don't have to be following my entire CityGen for me to show you how to set this up. I'll explain how you do this for your setups. But it does have a few prerequisites. One, you should already know how to set up high-gen partitioning with PCG. If you don't, I'll make sure to link it below as well as in the card here so you can learn how to do that. And the other thing is you need the PCGEx plugin, which is free, also linked down below. And of course, that means under Edit Plugins, make sure that when you search PCG, you have the PCGEx plugin enabled, and of course, regular PCG. And assuming you have those two main ones enabled, it'll enable any other dependencies, so you're good to go. But assuming that's the case, let me show you how to take any spline network and make it work with the high-gen partitioning of PCG. So here we are in the current version of the CityGen. You can see here, we have the spline mesh roads, but they don't partition. So to get started, let's go ahead and open the PCG graph that is controlling all of these. So one thing that you're going to need to do is make sure that you have unbounded enabled here by default. This is just so you can place all of the spline meshes and have them all be computed and connected to each other, and then you can partition them afterward. It's possible to do it the other way around. I feel like this is just much easier to do all your calculations as though it's not a per partition thing, and then go from there. But the first thing we need to figure out is where do we finish tweaking the splines? In my case, it's right here. Right before I create the spline into the spline mesh, this is where the last thing that I'm doing for these spline meshes ends. So right here, after this transfer points. So for your own systems, find wherever you're done doing anything you're trying to do with the spline meshes, and we go from there. The node we're going to need is, of course, a PCGEx node. Pretty much all of them are. And this is the Clipper 2 rect clip. Fast rectangular clipping using optimized Clipper 2 algorithm. And rectangular clipping is pretty much what we need, because partitions are basically just that. They're rectangles. Technically squares, but a square is a rectangle, so we're good. So we'll go ahead and detach this transform points from the rest here, and I'll plug this into the paths of the rectangular clip. Paths are basically just a connection of points that make up a spline, except it's not actually a spline. For the operands here, I need to put in the partition information. Well, I need to partition it based on something, or cut it based on something. So here, I can do get actor data. So that way we get the information of the PCG graph itself, so we know where this is partition is happening. But we don't want to have it on parse actor components. We just want to get the single point. If I was to debug this, you'll see here in the world is just write a big volume across the entire thing. Of course, we need it per partition. So yeah, we'll plug that through, but then on this get actor data, I'll go under settings advanced and turn on execution dependency required. This gets us this execution dependency input. From here, we can have a nice little note called set grid size. And this is where you specify the grid size that you want to use for your setup. So in my case, I'll drop it from 25,600 to 6,400, which is what I'm using for the rest, and I'll plug that through. If I go ahead and debug this rectangular clip by pressing D on it, I can go in here and fly in, and you can see, hey, look at that. All of these points are now being cut and partitioning. Okay, so this is working well, but now we need to spawn the points. Now you might be thinking, okay, well, at this point, I can just do create spline and put it back to where we were doing, right? And in a sense, you'd be right. You can do this. You can see here, well, there's solar splines, and then we will have lots of issues. We'll have issues here and in many other places. There's another issue one. There's going to be probably another one around here somewhere that has an issue. Yep, there's another place. So it doesn't quite do a good enough job. That's okay. We can modify this to clean this up. So in our case, we're no longer going to go into this create spline. We're going to use a few other nodes. I'm going to use the PCGEx spline mesh node, which is the PCGEx staging spline mesh. Now, in this node, we're going to need to configure a few things. So first thing is I want to turn off use stage points. This will let us add an asset collection. An asset collection, I guess, is basically a data asset that houses all the meshes and the information of what's being spawned. So instead of on this spawn spline mesh, us having the road straight here, we're going to have a collection that holds it. So for that, we need to go ahead and create the collection. So over in the content browser, we need to right click, go to miscellaneous, and grab ourselves a data asset. And up at the very top, you'll see all the PCGEx ones. And we want the collection mesh, responding meshes. So of course we need the mesh. Go ahead and select it. I'll call it DA_main road. And then I'll just open it up and you'll get this view. That's quite nice, but now how do we add it? Well, it's actually quite simple. And the easiest way of doing it is just go back to my spawn spline mesh node and click this folder icon to browse to it in the content browser. Then go back to our data asset and you can just click and drag and drop it in there. As simply as that. Now you see it's here. We can go ahead and hit rebuild to make sure everything is processed in here. And then we'll navigate back to it. So that way we can go back to the PCG here and plug in the asset collection just like so. Now I have noticed that occasionally when you plug this in, it doesn't automatically update and spawn the things. A good way of getting it to realize that everything is updated is to just detach it and reattach it. When you do this, we can take a look and there's our splines. Oh, Jesus, what's going on? Now, it is partitioning, but what is happening here? That does not look good at all. It's like it's clipping into the ground on these pieces. Well, actually, in a sense, it is. Because on this staging spline mesh node, down below under fitting, justification, it is setting to justify in Z. So it is effectively trying to move the points down because they're slightly above where our splines are. So I'm going to turn off justify Z. Don't modify the height. And when we do that, look at that, that's a lot cleaner. You can see here, it is working really well. And we now have partitioned setups, almost partitioned setups. We still have a few things here to kind of clean up. So things like this will still occasionally happen. So to fix stuff like this from happening and all of these issues, we need to recompute the tangents because clearly once we have a partition line, it doesn't really know how to do this because it's cutting them up even more. And in some places it's fine, but yeah, we can't have this. So after this rectangular clip and before the spline mesh, I'm going to do another right tangents here. So I'm going to drag out and search for right tangents. All this does is set custom tangents. In this case, I'll leave it in auto. There's a few options here, but auto seems good. And I can go ahead and plug that through. And look at that. That is nice and clean. That looks good. Oh, now we have a problem. We have a little cut here now, and we have a lot of cuts here. So in my case, and you might not have this, I was setting custom tangents specifically on the points that were touching the intersections. But in order to fix the partitioning issue, I had to basically overwrite them back. So now what I need to do is put the custom tangents that I had back onto the points and only the points where I need to. Because this loop rotation to tangent that I was using, which is just taking the first and last points and setting a custom tangents for those, won't work here. The reason it won't work here is because this relies on the full spline and the first and last point of that full spline, not the small partitioned version of it. But that's okay. I will show you how to transfer information from one set of points to another when they're overlapping. So what I'm going to do is go inside of this loop that I have. I'm going to add a new output here. I'm going to keep the old one and the old setup in case I ever need it. Before this new output pin, I'm going to call the label modify tangents. I'm going to set the allowed types to point and the pin status is normal. And all I'm going to do is take that first point, that one I was going to in here, the very first one, and the last point of the original spline, and I'll put them into the modify tangents out here. I don't even need to merge them. It doesn't matter. The main thing is I'm basically only taking the first and the last point of the spline and moving them out through modify tangents. So if I go ahead and just drag out here and do a simple debug, you can see there's our 4 points and you can see there's our 3, and it's only at the intersections. It is not per partition, even though you can see when I come out and fly in, these points don't move. They're not partitioned. So this is exactly what we want. So now after the right tangents, we have good tangents. We just need to use these. So I'll move the spline mesh further to the right and I want to sample these points. So I'll go ahead and use a new node, sample nearest point from PCGEx again. All of these are PCGEx nodes. I'll have a sample point that is going to go into the paths as before. The modified tangents will be the target of the nearest point. And now we just need to modify this nearest point setup. In the detail here, under sampling, we're currently sampling all within a range. I don't want to do all within a range. I just want the closest point because I just want to grab the overlapping ones because they're in the exact same position. Now you cannot do 0 and 0 here. It needs at least some range. So I'll just put in 1 for the max range, effectively overlapping. So that's cool. It will find the point from the target that matches. But then what do? Well, that's under blending here. Under blending, it says individual. We need to change it to monolithic. Monolithic will allow us to basically specify the attributes that we're blending. So I'll press plus here, and then I'll type in arrive tangent, and then I'll press plus again and type in leave tangent. If you want to make sure you type these in correct, they're the same ones that are under tangents here in the spline mesh. You can just select it, go back to blending on the nearest point here and paste it in. The thing we need to change though here, instead of none, I want to copy it from the target. So I'll select copy target. So whatever the arrive and leave tangents are on these overlapping points, copy them from the target. And now if we take a look, well, look at that. We no longer have this issue. Now, occasionally you will still have a bit of a problem like here. This is no longer at this tangent, but is just a slight issue here. Stuff like this does need to be fixed up just by modifying the actual spline here. So I'll just move this a little bit. And with a little tweaking of the actual spline here, you can see I am good. Now, the reason we have occasionally issues like that is because things might be a little bit too close together and they're basically on or near the actual partition lines. And when they're just a little too close, it can cause some issues. You have to be kind of mindful of your lane still, and depending on the size of your partitions, if they're very large, you're going to have less of these issues, but just fly through and see if there's some that you just need to slightly tweak, move a little left, right, and it will kind of fall into place. But the main thing is here, you can see the roads are actually connected and there's no gap here. And as I fly out, you can see they disappear. Now, we aren't taking care of these guys. And that one over there just got bugged out. There we go. Fly in, fly out, and we're good. So let's go ahead and now get rid of the intersections. For me, they're just right here. And that can be done the same way as I've been doing all the other stuff, which is just using a change grid size node, in this case set to 6400, into an intersection and a 2-point conversion node. I'll take all of that, just duplicate it over here and plug my points into the change grid size, and then that goes into the static mesh spawner, just like so. And now, if I fly in, you can see the entire thing disappears, but we still have all of these lines. So just like that, we have a nice setup with fully partitioned spline meshes, so we don't have to load the entire place. We just load what we need around us. As a little bonus, I'm also going to show you guys how to fix up this kind of really ugly bend from the Zone Graph plugin. So if you're following along with the series, I can show you how to fix this up. It's actually very easy to do on the cluster to zone graph. Right now we have the road point type set to auto Bezier. Instead, we're going to set it to regular Bezier, and then we can change the tangent length mode from default to auto, and we can change the scale here to something like 0.3. And you can see here, it kind of smooths this out. So this is 1, this is 0.3, this is 0.1, 0.5. 0.5 here seems like it's the best solution, so we're going to set it to be 0.5. And one final kind of little thing for the zone graphs is maybe you will have this on occasion where you kind of have an overlapping intersection mess here. This is really simple to fix. After the 2 clusters node, we just need a fuse clusters node. And on this node, once you plug everything all the way through on it, go under point settings, fuse details, there's the tolerance. Set it to something like 100 here. And by the way, if you're wondering why are we doing it on this node instead of the 2 clusters that also has a point settings and a tolerance here, for some reason, changing it here does not fix it, but adding this and setting it here does. And if you take a look, there we go, problem solved. And just because I can, on the simplify, I'm going to change the angular threshold to 3 degrees. And there we go. Now everything is working. It's all partitioning. We have a little ghost one. We'll just fly in, fly out. And if I go and simulate, you can see everything still works. And it's partitioning as though I'm at the center, which is why we're only seeing that part. But just like that, we now have an updated city that is fully partitioning. Now this is a slightly shorter video because I've been working on the traffic system. I'm making my own custom blueprint traffic system that will work with all of this. At least that's the hope. I can't promise that it's going to be the best traffic system in existence, but I can promise you it will work with the City Gen series that I've been showing, and it'll be full blueprints, because I don't know C++, and so I can't teach you that. But hopefully you'll join me for the ride. And as always, the project file for this will be available on my Patreon, where you can join these wonderful people in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord, everything else will be down in the description below, as always. And if you're just joining the series, knowing that spline meshes can be partitioned and you want to know how we got here, check out this video right over here to get yourself started from the ground up.